Next part of the chapter deals with surds. Now, surds are examples of irrational numbers. Those are numbers whose cannot be expressed as a fraction and whose decimal will never repeat. One we're going to come across before is pi. So other examples of surds are square root of n, where n is not a square number. So square root of 4, for example, we know is 2, so that's not a surd. Square root of 2, square root of 3, those are all examples of surds. And we can multiply them as well, so 5 root 2 is another example of a surd. There are some rules. Multiplication rule. Square root of AB can split up as square root of A times square root of B. And division, square root of A over B can separate up as square root of A divided by square root of B. Example 12, simplifying surds. So in A, I want to simplify square root of 12. As I said before, there is no non-calculator paper to worry about in A-level maths. You can just put it straight into the calculator and it will simplify it for you. But where would that answer come from? Well, if you think about the square numbers, 1, 4, 9, 16, 25, 36, 49, 64, 80, 100, so when you're trying to simplify a number, firstly halve it, which is 6. So 6 is here. And then going backwards through the square numbers, find which is the biggest square number that fits exactly into it. So in this case 4 does fit into 12, it's a factor of 12. So 4 times 3 is 12. So I can rewrite that as root 4 times root 3, which is 2 root 3. B, root 20 over 2. So I'm going to simplify the surd and then halve it. So 10 over 2, 20 over 2 is 10, but 9 doesn't fit into it. 4 does. 4 times 5 is 20. So it's root 4, root 5 over 2. Root 4 is 2. So you've got two lots of root 5 divided by 2, which just cancels to give you one lot of root 5, which is root 5. The 2's just cancel. C, this is an interesting one. We've got 5 root 6 minus 2 root 24 plus root 294, sorry. Okay, so let's start off by simplifying each of the surds. 6 over 2 is 3. The only square number that fits into it is 1, so it doesn't simplify. Now if we simplify all of this, this is a big clue now. This tells us that these are going to split into root 6, because that's the only way we're going to have a common term. So you think, what times by 6 is 24? 4. 4 times 6. And what times by 6 is 294? 49. So that simplifies to give me 5 root 6 minus, well, root 4 is 2. 2 times 2 is 4. 4 root 6. Root 49 is 7. Now, you can treat root 6 as x or treat it as your favourite animal. Think of it as a baby kangaroo. So you've got 5 baby kangaroos, take away 4 baby kangaroos, that's 7 baby kangaroos, is what, that 8 baby kangaroos, in which case is root 6. 8 root 6. 5, take 4 is 1, plus 7 is 8. You've got 8 lots of root 6. Example 13. Expanding involving surds. Root 2 times 5 minus root 3. Let's go for box number 3 and do a bigger box this time, yeah? I didn't need that bit, obviously. Root 2 times 5 minus root 3. Well, 5 lots of root 2 is simply 5 root 2. Root 2 times root 3, going back to multiplication rule, is just root 6. So this is simply 5 root 2 minus root 6. There's no more you can do with that. B. 2 minus root 3 times 5 plus root 3. Five times 2 is 10. 2 lots of root 3, simply 2 root 3. 5 lots of root 3 is 5 root 3, it's minus. Root 3 times root 3 is 3, minus. So those combine to give you 7. Those combine to give you 2 root 3. Take 5 root 3, it's minus 3 root 3. You've got minus 3 lots of this thing called root 3. Okay, that's all the examples up to exercise 1A.